The second paper suggests new triple modality imaging strategy for brain tumor surgery using MRI photoacoustic Raman nanoparticle. Brain tumor is general term for intracranial solid neoplasm within the brain or the central spinal canal. If it's in high-grade state like type 3 to 4, it is very serious and life-threatening because of its invasive and infiltrative character. Complete surgical resection is almost impossible because of the infiltrative feature of the tumor. Unfortunately, understanding about high-grade tumor is not that clear, so current treatment only relies on surgical resection. Prior to actual surgery, visualization of tumor site and area must be done. In order to achieve non-invasive tumor area imaging, MRI is widely used. MRI machine measures the nuclear magnetic resonance of hydrogen atom in strong magnetic field. It is relatively safe approach because it uses non-ionizing radiation, but MRI has low spatial resolution, which is inappropriate to delineate tumor margin with it. Photoacoustic imaging is another non-invasive imaging to visualize in vivo sample. Photoacoustic image utilize thermal expansion of the target when it is irradiated. Thermal expansion of sample generates acoustic waves, and these acoustic waves can be detected by ultrasonic detection. It has greater spatial resolution than ultrasonography or acoustic image, but yet inappropriate to image cell size sample, so tumor margin visualization with photoacoustic image is almost impossible. Raman imaging is another imaging technique which has very high sensitivity. In fact, Raman signal itself has very low power, so we should amplify this Raman signal by a phenomenon called surface-enhanced Raman scattering. Surface-enhanced Raman scattering can be achieved by another nanoparticles like gold nanoparticle. The nanoparticle in this paper can be detected by all these three imaging modalities. With this nanoparticle, we can get sectioning imaging of MRI, we can get high sensitivity and spatial resolution of Raman imaging, and good penetration depths and 3D imaging of photoacoustic microscopy. So basic concept of this MPR nanoparticle is shown like this. Leaky permeable blood vessel in tumor mass allows the nanoparticle to penetrate the BBB, possible to delineate the tumor margin. Each layer of nanoparticle can be detectable by 3 different modalities of imaging, so we can use those images in each part of surgery plan. First, they synthesize and characterize these MPR nanoparticle in many points of view. This 60 nanometer gold core surrounded by Raman active layer is protected by 30 nanometer silica coating. Laser observance, relaxivity, and optical observance during continuous laser irradiation are confirmed in this figure. And then they introduce this nanoparticle in mice and see what happens in the tumor margin. In the left figure, we can see how this nanoparticle works in mice brain. As you can see in before injection and after injection image, with these three imaging modalities, we can detect tumor margin with MRI, photoacoustic, Raman imaging. In graph C, they show signal to noise ratio by using this nanoparticle. In this figure, they can show this nanoparticle can draw the margin of tumor. After the verification, they actually introduced these nanoparticle in actual case, and they actually done surgery with mice brain. This MPR nanoparticle guide the brain tumor resection with MRI, photoacoustic, and Raman imaging. In figure B, it looks like all tumor has been removed, but in figure C, they showed some tumor mass are still remaining in the brain with the Raman imaging. This high sensitivity Raman imaging can, by taking advantage of all three modalities of imaging, led us to establish more robust and precise surgery plan. Non-invasive and pre-surgical imaging is possible by MRI imaging, and less cytotoxic than Q-dot. This nanoparticle led us to do non-invasive and pre-surgical imaging, and it is less cytotoxic than Q-dot or magnetic nanoparticles. So it shows more possibility to clinical translation. But in order to translate this nanoparticle into a real clinical case, more research should be done, because this nanoparticle needs new imaging system that can provide us these all three imaging modality during surgery. So maybe it's far way to introduce this nanoparticle in